Alright, now I'm going to discuss proof by contradiction. Alright, proof by contradiction. So here's our example. Prove that square root of 2 is not rational. Alright, so proof by contradiction starts with the assumption that the conclusion is not true, right? Which means square root of 2 is rational. So we're going to suppose that, okay, the proof starts like this. So proof, alright, proof. Suppose that what square root of 2 is rational. Alright, suppose that square root of 2 is rational, which means here, so we have square root of 2 to be equal to a ratio of two integers, okay, a ratio of two integers, m and n here, okay, and of course the denominator isn't 0. All right, and we may have seen one more thing here. We know that here we may do simplifications, do cancellations to the integers, so that there is no common divisor for m and n both. All right, so that means their greatest common divisor is 1. Right, so we may choose m and n to be in such a way that, right, so just like here, so let me give an example for that. So if this is 16 and if this is 12, then we may divide it so that it's equal to 4 over 3. All right, so there is no divisor, common divisor for 4 and 3 both. All right, so I'm going to assume that here greatest common divisor of m and n is 1. All right, I can assume this, and then we may take the square of both sides here, and we get 2 equals to m squared over n squared here. All right, and now that thing will lead to 2n squared equals to m squared here. All right, so that means you see that m squared is a multiple of 2. That means m squared is even. So m squared is even. All right, m squared is even. But previously we have shown that. If m squared is even, then m is even. All right, then m is even. So this was proven before. All right, I mean we have proved the contrapositive of that statement here. If m is odd, then m squared is odd. All right, so this is the contrapositive of that. So if m squared is even, then m has to be even here. All right, and now if m is even, then m is a multiple of some integer here. Okay, a multiple of some integer. All right, so let's try to use this equation again. So 2n squared has to be equal to 2k squared, all right, which is 4k squared. That turns out to be now 2n squared has to be equal to 4k squared, all right, and a little bit simplification, n squared has to be equal to 2k squared here. All right, now just similarly for the case form m here, we have n squared to be even.